Hello, everyone, and welcome to Answer Everywhere. Today, we're taking a look at Adventure Game Studio, which is a game engine toolkit that allows you to build adventure games like the classic point and click graphical adventure games that were cool many years ago, maybe like the 90s, late 80s, and have sort of evolved into other genres. But Adventure Game Studio, I think, is squarely made at kind of making some of these retro games. I posted a video last week of my brother and I trying to play through what might be considered kind of a modern version of one of these games, which is called Disco Elysium. And the idea there is that's just a story-based game that is a little bit, from on this channel, we're looking at how things are made, how things are created, software so far. But there are other sorts of things that you can create. And one of them is like films or movies or stories. And I think adventure games are kind of the genre that's like an interactive story, not quite a film, but definitely in the video game camp, but using kind of more film elements where the idea is that the user gets to interact and evolve through the story as things go on. So you can hear some screenshots of what Adventure Game Studio looks like. And I guess if I click on them, they go away. But you can see that it's a relatively, to my eyes, older looking UI. Maybe like an old version of Windows. I haven't used enough Windows to know kind of what era this was. But I think there should be, I think that because this is focused on creating this specific sort of game, I think this will give us an appreciation for the logic of these games more than simply looking at a more general purpose game engine that allows you to make other sorts of games, among some of which are adventure games. All right, so that being said, let's jump in. Here's the code base on GitHub. And one thing that I see that's a little bit, I'm not sure how to handle it or think of it, is that we have a mix of C++ and C, which on its own is not so surprising. But then we also have C#, and we have like 17% C#. And then we have Java, which is, I kind of think of C# as Microsoft's attempt to make a Java clone. And so C# and Java are kind of similar, but they require different VMs. So I'm not really sure what's going on with all of these different languages, where they fit in. Maybe one is for scripting and the others are implementations. I don't know. In fact, why don't we check out Adventure Game Studio scripting. One second. All right. Let me try this again. I'm having some OBS issues. All right. Sorry about that. Cool. All right. So, scripting. We have Introduction to Scripting, Part 1. All of the interactivity in the game is handled using scripts. So this is an interesting and important point, I guess, that I'm glad that we see it early, which is that if we take this sentence literally, this means that there's no like game logic interactivity that's handled outside the scripting system. So when you're creating, I guess, a game using Adventure Game Studio, it's really all about writing the scripts, and you're not going to be having to toy with any of the rest of the engine that might be implemented in other languages. Assuming you've done the main AGS tutorial. which I haven't. You create a script that looks like this. So this looks like a C-based language, possibly C#. But let's see if we can find the tutorial. Or what language does Adventure Game Studio use for scripting? Let's ask Google, because Google tends to be a little bit better. All right, but scripting based on the C. So maybe this is a custom language. All right, well, we'll find out. So we look at the code. I think I was looking in GitHub, but I guess there's no real reason to. Let's look in Emacs. All right, so in the root directory, we see a few things. One is editor. This is going to be some sort of editor. I don't know of what. Probably of, I'm going to guess, just to throw something out there, of worlds, like of 2D graphics. Let's see if I can find it. Editing worlds in Adventure Game Studio. Let's see if I can find a like an image of what it looks like when you're using like I think something like this, where you have essentially some image in the background, and you're going to like select areas of the screen, like you would select rectangles for these doors, and mark them somehow as this is an element that the user is going to interact with, such as by opening. So I think that that's probably the sort of stuff that's going on in the editor. We'll see. The engine is presumably going to be the game engine. LibSource is a pretty generically named, but this could be, my first thought is maybe that this is, LibSource is essentially vendor dependencies. We have download and tar extract. Yeah, I think that this is vendor dependencies, like Vorbis. Okay. Script is presumably going to be scripting support solutions. That sounds like a directory named by like a business consultant. But are these solutions to puzzles? Engine solution? Yeah, I don't know. So we'll take a look at it. I'll mark it. I'll make sure to visit it. Plugins and PSP. I would guess that a lot of the functionality might be built in plugins, but who knows? It kind of depends on how robust the ecosystem is. So for example, we see Lua. Presumably this is a plugin to allow you to write scripts in Lua. Let's see if we can find any comments. Yeah, I don't know. But we do see here something about the plugin system, which is that this is a C file, and we have these functions, module start and module stop. I'm going to guess that these are called by the plugin engine, but we don't know for sure yet. And then we have Flashlight, Blend. I'm not sure what Blend would be. Parallax is presumably support for like visual parallax, and then stuff about sprites and rain and that sort of thing. PSP, I'm not sure. We have a kernel, a launcher, a lib, media, mallet. So PSP kind of seems like the gameplay area. Let's see if we get like any sort of comment in kernel. Not in there. PSP module info. Is PSP a piece of hardware that it's supporting? Because we saw OS X, AGS engine, PSP support. Is this PlayStation? I'm gonna guess. Oh, or is this the portable PlayStation Portable? Yeah. Okay. I think that this is probably support. I think I clicked on the wrong thing. I think this is probably support for the PlayStation Portable thingamajig. You get a picture of it. This thing. I'm gonna guess that's what's going on in PSP directory, and ignore it. Yes. And we also have OS X, which is in iOS, which are going to be like hardware or platform dependent parts of Adventure Game Studio. Mscripton is the JavaScript standard, essentially. I don't know what we're doing with JavaScript, but it doesn't seem like a lot. We install dependencies, launcher window, mygamefile.js. Fill this array with all your game files and put them in the same location. So possibly this lets you play the game in your browser. I'm not sure, but we'll, I guess, ignore that as well. And then we have common and compiler. CI and CMake are going to be continuous integration for CI, and CMake will just be build stuff, so we'll ignore them. Android will also ignore. And then common and compiler, how big is common? Common's got a lot of stuff, so I guess we should look at it. And the compiler, who knows? Compiler.h. The script compiler core. Okay, so this is the compiler for the script, which is good to know where that is. I'll flag it as well. And given what we have, common compiler, editor, engine, script, and solutions. I'm kind of most curious about solutions, just because I don't know what it is, but I'm going to start in common. And I guess let's start in core. And in core we have assets, asset managers, and types. So let's start in asset, I guess. Asset info and asset lib info, classes describing generic asset library. So I'm guessing by, I don't know if the word library is doing any work. I'm guessing these are just describing generic assets. So an asset info has a file name, an ID, basically a unique ID, an offset, which is, I guess we're going to store, the file storage will basically be serializing one asset after another in bytes, and then we just store in some sort of index, maybe what the offset of the byte array is, and then we have the asset size in bytes. Okay, so that's straightforward. And we have asset lib info, and we have a base path, a base dir, and a base file name. I assume this is like, you know, you open up Adventure Game Studio, and it will basically ask you where do you want the root of your project to be, and that's the sort of stuff stored here. And hello, folks on the chat. It's not quite a game, but a tool for building games. And Doraj was saying that I was probably right about PSP. Yeah, I think that's right. Okay, so assets are straightforward. It's basically where is your stuff, and then we're going to serialize everything and like pump it into a single file. And then types should be basic type definitions. We've got this force inline macro, which is, these aren't, I guess, varying a lot, but they do depend on whether you use, I guess, Microsoft or the GNU compiler. And then we have a fixed point type and a color type in a enum that has like a, I guess we're going to frequently shift by 16, and then we're setting KUnit to, I guess, 1 left shift, and then KShift, which is 16. What that's doing, I have no idea. So core, there's not a lot in core. We have platform, which I will ignore, and def version, which is just going to print version number, right? Copyright years, 2011 to 2023. Okay, there's not a lot there. Debug and font, I will ignore. Game, we have main game file, that's DPP, and main game file.h. I'm guessing these are just essentially a software model of what the entry point for your game is. Then we have a room file base and a room file. I'm guessing this is, the real thing is room file, and then we have like some sort of base. Maybe they have a tree or some sort of structure where room files. If you imagine the adventure game, like we just looked at that picture of the door, is that still up? We have the PSP up. Unfortunately, this is not a high-res graphic, but you know, behind the store would be another room, which, as you're playing the game, the idea is to make it seem like this is another room in the same building or whatever. But from the engine's perspective, there's just some graph, I imagine, of rooms, and then there's like a link between an arc in the graph between one room and another, if they're connected in the sense that a player can walk from one to the other. So I'm guessing that's what room file is. But let's open these. Maybe just the header. room struct, I guess let's look at, no idea what a trough file is, but things that get abbreviated are sometimes important. And then interactions looks important. We'll look at the custom properties header, and we might as well look at main game file.h, and let's start there. So 159 lines, not bad. And we've got some things that seem like options, like is main game library, find game data. Now these are not options, these are functions with kind of a weird formatting. The function name is justified rather than being like a fixed number of spaces from the return type. And we just got things like update game data, etc. These are rather, I guess, generic functions, it looks like. Load game entities. So this is meant for keeping objects loaded from the game file. So this is going to look into the asset stuff that we saw, kind of how to configure, and load the files into some sort of vector, I assume. So we get a vector of scripts, a vector of plugins, a vector of dialogues, and a vector of views. I kind of want to know what a dialogue is. Then we have game source, which is you basically have a name of the asset file and a version string, probably a description, maybe somewhere, what you compiled it with. Maybe you don't have a description. Okay. So let's look at a dialogue. We have dialogue scripts too. Dialogue topic. Okay. Dialogue topic is the type. So what folder are we in? Common/AC. What is AC? This has things like audio, key code, sprites. No idea what AC stands for yet. If you have a sense of what AC might be, let me know. All right. Okay, so for dialogue topics, we have a list of options, essentially, looks like. Max topic options. A list of flags, option flags. A list of entry points. And startup entry point. I guess this is maybe the initial entry point. Whatever code size is, maybe just keeping the size of the dialogue topics all together, I don't know. And then the number of options and the number of topic flags. Okay. And then we have this vector of uint8s, which is called option scripts. Option scripts is an unknown data from before AGS 2.5. Okay. And then we have these functions that are like read and write, and that's it. So what are we going to do with these dialogue topics? Presumably they're in some, that's told to us in the script directory. I guess we can't maybe get here from, maybe it's not in this folder. Wait, what? Wait, I need to spell this correctly. Find references. Okay, so where do we use dialogue topic? We have engine AC dialogue. That might be interesting, although it's not. And we have this implementation, the CPP file, and we have the main game file that refers to it. And that's really it. Maybe let's take a quick look at the CPP. There's really not much here. You know, this is reminding me of, there's a guy, Casey, I forget his name. I think he's the same as the Handmade Hero guy, who has this this talk about the difference between structuring your code for performance, like you would do in a game engine, and kind of structuring it for readability and like distributing essentially readability across like a an organization. One of the differences between those two is that when you're optimizing for like making your code maintainable and readable across an organization, you tend to break things down into like really small parts that can be composed or combined, and often in like Java style, they can be extended by inheritance and those sorts of things. And to me, so far, this code base reads a little bit like that's the route they're going down. That all of the files seem very small. We have like a small number of methods, and it takes a while to kind of dig through all the things and find out where the functionality is. That's my initial sense, at least. All right, so let's see if we can find something with scripts, because I know that I've seen it. Let's just try graphing. I found too many things. How about scripting? And I think this is a case-sensitive grep, so let's try script, capital S. This is more promising. We have register script function, return script load file, and whatever cirrus.yaml is. We're getting a bunch of hits in room file and some hits in reconstruct and interaction. So those were all things we already opened. So I guess what the world is telling me is that to understand scripts, I should understand those things first. So let's see if I can find that buffer where I open these all. All right, so we looked at the main game file. Let's look at room file. This unit provides functions for reading compiled room file. So maybe this is just for reading, we'll see, into the room structure, as well as extracting separate components, such as room scripts. So I guess the room file potentially will have scripts, the scripts that go on in each room. I guess it makes sense to store them with the room. If we're including functional, maybe we're doing some functional stuff. And we have the sprite info script struct that is, where do we terminate? I feel like, I guess we terminate down below. This formatting is throwing me off a little bit. I guess inside the oh wait, did I say this was a struct? This is not a struct. This is a class. Yeah. Oh no. Sprite info is just terminated here. I got confused visually. Okay. All right. So we have this room file error type. These are just different errors, like I couldn't open your file, the data sucked, etc. Then we have a room file block, which has things like the main room data. So I'm guessing oh no, it's an enum. Okay. So maybe this enum is telling us, like, we're saving the data in blocks. Is that what it means, or chunks essentially? And this is telling us what a particular chunk is as we're parsing it. At any rate, it might be the main room data. It might be script stuff. It might be old script stuff. And it might be room names or backgrounds and whatever contemporary compiled script means. And script names of the room objects. Okay, so we're just packing all this information. And I guess probably the reason this is an enum is that they're going to be used for parsing. We have the room data source, open room header, etc. Okay, so we should be parsing them into a struct, right? Room struct. So let's look at room struct. That's, I think, what we really want. Is that what we just looked at? No? Here we go. Room struct, that's CPP. Okay, here we go. All right, and so we have options for each room. The room can have startup music. Save load disabled. I don't know what that means. Save load. Maybe like you can save the state from a loaded file. I mean, you can load the state from a state. Load the state from a saved file. Is possibly what that means. Player character off. Maybe that's used for like cutscenes. Player view. I don't know what player view might be. And then you can control the volume and maybe have some flags. You might share the palette with other rooms, I guess. This is a room background frame. And we're just going to call memset of the palette. I guess if we're not sharing the palette, we're going to just zero out the palette, is basically what this is saying. And then we have room edges. And left, right, top, bottom. I'm not sure if we're assuming that everything's a rectangle, then maybe these are essentially, when you make a room edge, you're going to tell it, give it a coordinate system by passing integers into left, right, top, and bottom, perhaps. And then we have room edges. and room object info, which includes things like the sprite, X and Y. I don't know what those are the X and Y values of. Room, defaulting to -11, whether it's on a baseline of flags. Room object info. I don't know what a room object is, whether it's an object in the room or something else. And we have a room region, which doesn't actually contain any information about the region itself. It just has whether it's light and its tint. And then a walk area, which has a character view, a scaling far, and a scaling near. So maybe this is like if you're like walking off into the distance to get the perspective right. As you're far away, your character gets smaller. Maybe that's what scaling far is. And then maybe in the mid range, you scale also, but not so much. And that would be, I guess, instead of having like a continuous scaling factor for both, I'm not sure. Then whatever these player view and character view things are, I'll look at them in a little bit, and then we have top and bottom for the walk area. But not left and right, right? I'm not sure. Walk behind. I think I saw, so there's a video I watched of somebody putting together a basic game in Adventure Game Studio, and I think I remember and I watched this like months ago, but I think that what I remember is that you can essentially, let's say you create a desk or a piece of furniture, you can have the character walk behind it instead of in front of it, and the way you do it is you basically, you toggle walk behind. So I think that that's what walk behind is for. And then what else? We can freeze some stuff, which is like, we finally get to an implemented function, it looks like, room struct free, and it's like the largest function we've seen. It's just resetting stuff. Free messages, free scripts, and then we have initial defaults. And I don't know. Okay, so here we have, this will tell us what edges is. Edges is 0, 317, 40, and 199. Yeah, so I think that these are somehow coordinates to the rectangle, probably in a straightforward way. And then we have whatever a room hotspot is. I'm guessing a hotspot is maybe a place where you can click on, like there's a player action. Let's see if we can find a hotspot. Yeah, is this where we already were? Wait, didn't I go to definition? This is a CS file. I'm guessing it's in C# from the lack of Emacs support for currently. Maybe room hotspot is defined in this file. Here we go. A room hotspot description. We've got a name, a script name, presumably the name of the script that is going to execute when the player like clicks on this hotspot or whatever. A string IMAP, rather, which has got some way of encoding properties, essentially configuration that is flexible. We have old style interactions. Sounds like we've moved to some other new interaction system. And event script links. Okay, so event scripts. I don't know how event scripts differ from regular scripts. And then the point to walk to. The player will automatically walk here when interacting with the hotspot. So I guess if your player is like I don't know, if you're here on this like pedestal and you click on this machine, presumably your player will walk over to the machine to try to touch whatever, maybe touch some button or whatever. I'm guessing that's what walk to is for. Okay, that's pretty straightforward. We have a hotspot, and it's going to have some script, and your player is going to walk somewhere, and that's mostly it. And then there's some configuration. Let's take a look at interactions. Interactions. And we are what? We're in C++. And we have this equals operator, which I guess is not so interesting. Is it interesting? We've got some list, and we're going to resize it. And we're going to walk over, we're going to iterate over everything and set events I, the interaction event, and I.events, and return this. Huh. Oh, this is, I guess this equals assignment as in equals equals. Okay. Copy times run. This will, I guess, run it for some number of times. Copy, no. Maybe we're just copying the number of times run. I don't know. I don't feel like reading that for very carefully. Okay, so create from stream. So we can have some stream. I don't know what kind of type this is. There's some class. Read bool protected, write array of int8. I guess it's essentially some array, an array of int8s that has some behavior. I'm guessing. Unless we're importing something. We're importing an IAG stream. The contract between for stream classes provided by the engine to plug in on the need, such as saving and restoring a game. Okay. So whatever streams are for is valid. Get length can write, read int8, read int32. So this is like reading and writing from various arrays. I guess like a homegrown stream API is maybe the way to think of this. All right, anyway, we can create from a stream, and we're just going to do a bunch of reading and writing and setting up things. We can write to a stream. We can write the interaction to the stream. We still don't know what an interaction is. Write to save game. Read, write, etc., etc. Interaction variable. Okay, so we've got this interaction variable thing, which has a type and a value. And we can create one and give it a name. You can read and write interaction variables, and we can create them from streams. But what does it actually do? Huh. Is this all we get? Maybe we should have looked at the header. Interaction structs. Most of the interaction types here were used before the script and have very limited capabilities. Okay, so it sounds like this framework of interactions predates scripting for Adventure Game Studio. And so this is the legacy. This is some legacy stuff, which we've seen in the notes, the comments in the other files. The way this works, we've got some interaction on a hotspot 1, I guess, and some event types. I guess these are events that are, I don't know how we listen for events, but maybe we'll see that. And then an interaction command list, like look at hotspot, like if it's a, like look at door, I guess, or look at graffiti, if that's a hotspot. And then we've got each, I guess the interaction command list contains interaction commands. And then, I don't know what display message means. Oh, I guess when you look at the hotspot, it's going to display some message. Is that what it's saying? And then we've got interaction values. And we've got a list of them. And okay. So we'll just take a quick look at this. Since scripting is so, in theory, like if you have a Turing complete script, there's no real structure to the scripting itself. So the reason I'm looking at this outdated interaction stuff is I'm curious to see if there's any structure here that tells us more about how you would want to think of adventure games. Now, naturally, whatever structure it has will be limited, but it will at least be some structure that will possibly tell us something. So we have this interaction command list. It represents a list of commands or actions that need to be performed on a particular game event. Okay, so we have actions to run and some list of them. That's really it. What order they run or whatever, I have no idea. It doesn't seem to say in the documentation. Let's look at what type this interaction command is. Construct. And we have things like just some integer type, some I guess a list of arguments, some sub-actions, a parent, and so we've got some sort of graph, I guess, and we can assign them. Okay. That's enough interactions for me. And that's enough rooms for me, I think. Did we look at all the room stuff? The rooms can have hotspots. We've got some list of hotspots, list of regions, places you can walk. I think we saw a lot of that. All right, what else do we have? Where's my Duret buffer? Was it in core, I think? No? Common? I think it was in game. All right, so that was the room file. Let's look at, I think we looked at room struct. A class describing initial room data. Because of the imperfect implementation, there is inconsistency in how this data is interpreted at the runtime. Some of the data is never supposed to be changed at runtime. Another may be changed, but these changes are lost as soon as room is unloaded. The changes that must remain in memory are kept as separate classes. See room status, room object, etc. Partially, this is because the same class was used for both engine and editor, while the runtime code was not available for the editor. Okay. All right. This is kind of just like implementation information, I guess. We've got room area masks, and I guess the masks are going to be like essentially some bitmap. Maybe that's the whole, presumably the size of the whole screen, and then it says it's 0 in most places, and then it's 1 where the mask is active. And so a hotspot mask would be presumably one that has ones only on the pixels that are counted as the hotspot. I'm going to guess. Not positive, they could have done it in some sort of crazy way. We've got some volume modifier stuff, some flags for the room, I guess stuff about frame locking. I'm not sure. Is that cool? I don't know. And then you can have at most 50 hotspots in a room. I guess it would be a pretty intense adventure game that had more than 50 hotspots in a room. And you can have some max of objects, although I don't know if I don't know what counts as an object, because your drawing can have as many things on it as needed that aren't represented in code in any way, for example. All right, then we've got these room options, which I think we've seen, but now we get a definition of car off. If character is turned off in the room, all right. And then player view, we finally get a definition. Apply player character is normal view when entering this room. And then what's the other view? Wasn't there a character view? Yeah, okay, so character view is a part of walk area. And a character view says, apply character's normal view area. Huh, how's that different from player view? Optional provide for a player character view. I have no idea what this is supposed to be, but they're there. Then whatever a trap file is, this unit provides functions for reading compiled translation files. Okay, this is like translation stuff. Interactions, I think we looked at, right? So that's fine. Did we look at the CPP? I'm not sure. I don't think we really need to. Looks like lots of reading and writing. And then custom properties is probably not so important. Custom property schema is kept by game setup struct object as a single instance and defines property type and default value. Every game entity that has properties implemented keeps custom properties object, which stores actual property values only if ones are different from default. Okay, so custom properties. All right, so that was common, right? We looked at core. Is there anything in graphics? We have bitmaps, whatever an Allegro bitmap is. Allegro lib. Okay, there's some lib. And we have a GUI. We have things like buttons, I don't know, invis, in window, who knows, list boxes, main. These are just like point and click thingies, and we have a text box. I don't know how they're doing. They implement their own GUI system. Let's take a look at GUI object. We have things like get height. That's like the CPP file. I'm just trying to see if there's anything like they're using an existing kit. I'm not sure. Let's take a look at main. The header, I guess. Yeah, I don't see them importing anything like GTK or whatever. I guess you don't necessarily need that stuff. But this kind of puts them in the business of drawing things directly on screen. Is that what they want? Maybe it is. I don't know. that seems harder than just building and maintaining an adventure game library. All right, so what else is in common? We have libsource, which is third-party stuff again. And then we have libinclude, which is more third-party stuff platform, just as Windows. Script, I don't think we've seen this one. The C script style compiler. So we're compiling the script. And we have global num fixups. I'm not sure what a fixup is. They're fixing some stuff up. And this looks like just a straightforward compiler stuff, like nothing particularly video game specific. See if you can find any information about fixups. Sure, fixups. Huh. I don't really see anything that's super informative. A quick look. Let's move on. CC common, script options and error reporting. Okay. So we have things like, should we include the line numbers, stuff about configuring imports, and yeah, really not much. So that's script. Then we have tests. Tests are always good. And then utilities for things like compression, buffered streams, bebop, in case you want to listen to some music, I guess. Matrix, this is maybe just matrix math. Help our matrix functions to ease use of GLM in simulated 2D space. Okay. Well, that's common. What do we have that's above common? We have compiler. And I'm going to guess, based on what we've seen before, that this is going to be this is going to be like implementing a pretty generic script that's not super adventure game specific. So we have a compiler, we have a tree map, which is presumably kind of like a hash map implemented as a tree, a symbol table, a macro table, etc. This just is C-style script compiler. Mimics original interface, but uses standard map for storage. Okay, so we're going to use standard map to store stuff, and maybe we're using map to implement a tree. You can find value, add entry, clear. Okay. So, is there anything here that's adventure gaming? I don't think so. All right. The editor and the engine are presumably going to be adventure gaming, and then we have scripts. Scripts are they seem to be scripts for managing the Adventure Game Studio source code themselves, rather than like scripts for the games. I don't know what an SOLN is. Solution file, is it Visual Studio file format? I guess this is like whoops. Yes, kill anyway. This is like just essentially metadata to help the programmers work in their preferred environment. So we're left with editor and engine. And which one's cooler? I'm going to guess editor is cooler. We've got this plugin stuff. I'm in the engine right now. We've got this. We had some plugin stuff. We've got script.h and script.cpp and runtime script value. I guess let's look at script.h and script.cpp. We have object event. A struct holds data of the object's interaction event, such as the object's reference, and accompanying parameters. So this holds things like a pointer to the object and some parameters or arguments for it, I guess. An object event. The name of the script block to run may be used as a formatting string. Okay, so the block, I guess, has scripts like any, the script has blocks like any other programming language, and I guess somehow they're named. Maybe you have to name the blocks when you write the script, I don't know. We have an ID for the block, and then runtime script value, which is a Dyn object. the dynamic object this event was called for, if applicable. An interaction mode. And what kind of modes do we have? I don't think this is graphics mode. Oh, it's just an int. What I really want to do is look up mode none. Here we go. All right, so the modes are, I guess, things you can be doing like walking, looking, talking, handing. Hand, whatever hand is. Use or pick up something. Okay, so those are the sorts of things that modes are. And we've got some default setup stuff. And we can run dialog requests with some parameters. Why is it a request? I don't know. And when you request to run dialog, first they're going to stop playing the dialog. Wait, play.stop playing dialog at end is set to dialog running. Okay, so that seems to be some sort of state. And then we are going to run script function, game inst, I don't know what game inst is, and we're going to get something from it, possibly the underlying pointer of a smart pointer. We're going to pass in this dialog request thing. This is, I guess, the name of this sort of message that we're sending, perhaps, and then some params. And then we have essentially a state machine based on the setting of stop dialog at end. And how does that get set? I'm not sure, but we set it here. And so now when we get down here, I guess we're expecting it to have changed. And based on the state, we're going to do various things, like return -2, return tval, which is, I'm not sure how to interpret tval. We're going to subtract the dialog new topic from stop dialog at end, etc. So this has some return values that have some sort of meaning that's not obvious to on an initial reading, but it's doing some sort of attempting to run a dialog. You can run a script. We can run a function on a non-blocking thread. We call update script mouse coordinates. I guess that's telling the script where the mouse is. Room changes is set to play room changes. At least one implementation exists. It's set to false. Huh. Not sure why you would do that. And then we're going to run modules. Modules need a forked inst for this to work. So we're going to iterate over the script modules. We're going to set module has function at the index I to whatever do run script func can't block module inst fork cat, etc. Huh. I'm not sure what this this code is doing. I find this style a little bit confusing to read, but that's all right. We'll keep plowing on. All right, and so and now we're back in script.h. You can do things like run an interaction event where you pass in an interaction, some int, and some other stuff. Runs the object event using an old interaction callbacks type of event index, or alternately, check any index if previous does not exist. Is in tells if this was an inventory event. It has a slightly different handling for that. Returns 0 normally, or -1, telling of a game state change. Okay, so it's some kind of like callbacky thing whose behavior it seems like has changed over time, and you kind of have to pass in different things depending on which behavior you want. You can also run interaction scripts, run blah, blah, blah. Then you've got this runtime script value stuff. Try to run a script function on a given script instance. I'm not sure what a runtime script value is. Do we look at this? It can be undefined. And then we have this I value pointer. I'm not sure what magger pointer is, maybe manager pointer and a size. And I think we did see some of this. Okay. So this is more script stuff. That's fine. We have a script API. Maybe this will tell us something interesting about the structure of scripts. We can print f. And what? Okay. So this is, I guess, the, yeah. So we have a bunch of ways the script can, I guess, call into C is really what this is doing. And we're going to call printf. We can assert object count stuff. We can assert various things. Helper macros for script functions, asserting and for internal mistakes, etc. More printf stuff, calls to static functions. Important, please note following. Historically, AGS compiler did not have proper void types and allowed to store the return value of void API function as an integer. Okay. So you can call a function, I guess, by passing in my name. And then we have this weird void pn stuff. I guess it's not weird. I guess the first thing is maybe the return type. Is that right? And the second thing is the parameter type, because this is, for example, pn2, and it's taking int32 here. And so we're, this is just essentially, we have to make one of these things for every way that a script wants to call one of the functions, I guess, of the AGS system that's in C or C++. All right, so that's script. We also have media. That's probably not so important. I'm going to guess main is not so important. We have game run. Should we look at game run and game start? I mean, these are presumably going to do, you're going to just bootstrap some stuff, initialize, start, and gameplay. This is like set cursor mode to walk. I guess you begin as walking. If override start room, you might override the start room for some reason, maybe for debugging. Then you load the game, and you run game, I guess, until aborted. Basically an infinite loop that you can escape out of. Okay, engine setup, is that interesting? So engine, I think they're thinking of as the just the interface with the graphics, because this seems to be all about graphics system stuff. And that's fine. And then for engine, we've got things for like support for devices. What is game? Game is like save games mostly, but also a viewport. And the viewport, I mean, we've got some stuff like cameras and viewports. I guess that makes sense. They were going to be somewhere. I'm not sure why they're in this folder in particular. And a camera has what? Camera defines a looking eye inside the room, its position and size. It does not render anywhere on its own. Instead, it is linked to a viewport, and ladder draws what the camera sees. So this is the standard thing, I think, that you get in definitely in 3D software. Maybe also this is common in 2D software. We've got some rectangle, that's the room camera position. And we can set the size, I guess, of the camera, whether it's locked. We can release a locked camera. And then the viewport is just going to be the thing that is shown by the camera. Where's the viewport? Last viewport here. Viewport defines a rectangular area on game screen where the contents of a camera are rendered. And you can only link one camera to a viewport at a time, which makes sense, and it's basically just some rectangle and whether it's visible. All right. That's engine. And let's see, I think the last interesting thing is editor. And we've got native, which should just be things like support for Windows or whatever. Scintilla, I forget what Scintilla was. We have some Lightning stuff. All tip, case convert. Is Scintilla font stuff? Did we look this up? Let's do Scintilla Linux. It's a free open source library that provides a text editing component function. Okay, so this is, I guess, for editing text, presumably. Which you may need to do in your adventure game. Or maybe, I guess it's for the editor, so that you're like writing a script or whatever, you can do that in the adventure game studio itself. References.txt. Following assemblies must be included in this directory. So this is something about building. And then we have types, native. I'll ignore native. We've got the script compiler, controls. Let's look at controls. Let's look at editor. Let's look at types. Do types first. CS. So CS should be, is it C++? CS file extension. I mean, not C++, C Sharp, right? Yeah, okay. We have a C Sharp mode. All right. So we've got like audio clip stuff, folders, basically where they're stored. Not a whole lot of interesting, I guess, technical stuff. Things like build targets. The audio clip itself, is that interesting? Whatever I2XML is, convert something to XML and directory, source file named, some identifiers, volume. I'm not sure what this, these are some sort of, I guess, annotations on functions in C Sharp. I don't know. They kind of look commenty. And this is all kind of like where things are stored, where can we get the files, etc. Interactions. We've got a schema. I don't remember seeing an interaction schema, but maybe that's a thing. And again, this kind of seems like a lot of boilerplate. All right, that's not that basically what I expected. That was what, the types. Is there anything else in types maybe? Enums are interesting. Font height, game scaling, log group, lip sync type. What are the different lip sync types? Palette colors, room, what was it? Room volume. What's like a lip sync type? None, text, or Pamela voice files. Maybe Pamela is some way of synchronizing, encoding lip synchronization in a file, I guess. Constants, are constants interesting? A little bit. Different masks, right? We look at dialogue. We've got a text parser, which you can possibly show. In the dialogue, we've got some script from the dialogue script file. We have identifiers. Whether to show a text box along with the options so that the user can type in custom text. And then if you type in custom text, I guess you have to parse it, and maybe that's just done in the script. I don't know. All right, so that's types. Let's look at controls. And we get Scintilla stuff here, address bar stuff here, assembly info, and Scintilla helper. This all seems to be address bar and Scintilla related. Address bar extension, dot controls. There is some extra error handling, and most of the method that in theory is redundant. For performance reasons, you should remove a lot of the information. Okay, so controls doesn't seem like the most cool thing. And here's the editor, and we get things like entities, enums. Let's see what an entity is. A multi-select action. Log buffer get script editor control event args. Editor preferences, speech lip sync line, recently edited game, zoom to file event. Okay, these are all these seem like everything in there kind of is legitimately there to support the UI rather than something specifically adventure gaming. We have play finished handler, which can do things like play, check whether it's playing, poll, presumably poll the thing that's playing stuff and see if something else is playing maybe, get length and get position, and stop and resume, etc. Okay, then we have panes, plugins, properties, resources. Tasks, what's a task? Have you seen tasks? Construct basic file list for template. Create a new game from template. Maybe a task is like a script. Load game from disks. Yeah, these things that are tasks look basically like scripted operations. All right, is that it? That seems to be it. I kind of feel like I don't know if it's just the way the code is structured, but it kind of seems hard for me. I feel like I'm missing something right now with what Adventure Game Studio is doing. But I guess I guess maybe it really is all there. So let's go back and look at an example of just here. And let's see if we can find a higher resolution screenshot. Let's just try Adventure Game Studio. And choose a large one. Oh, are there any wallpaper size Adventure Game Studio screenshots? I don't know that these are actually of the thing of the. All right, so here's a slightly more higher resolution screenshot. So all of these dialogue stuff that will be in the folder we just saw. And I guess if the making of the game itself is I guess pretty straightforward, right? Once things are set up, once you have the right model for how to do it, I'm sure there are lots of hard ways to build an adventure game where you kind of get tangled up in knots and everything. But you're going to just have a series of bitmaps in this like older style game, and each bitmap will have masks, and we've seen that in the code. And then those masks are going to select regions, and when you go over that region and you click on it, your character will move probably there. Typically, in the typical case, they might move somewhere else, and you will execute some sort of script. And that script can, I guess, in theory, be anything that you can express in something like C or Lua, confined to the limitation that the number of like the library functions you can use are the ones provided by Adventure Game Studio. And as you build out the game, you're going to build up this graph of rooms, and that graph, I think we saw at least some of the stuff related to how that graph is stored. And I don't know if there doesn't seem to be, at least as I'm looking at it, a way to encode like a puzzle. Like a lot of it in adventure games, you'll have to, get the piece of paper from the guard and show it to the king, and he'll give you a scepter or whatever. I don't see that explicitly, those sorts of puzzles explicitly modeled. And maybe they're just implicitly modeled by how you code up the interactions and the scripts. But I think like you can look up like a puzzle dependency graph. This purports to be one. I don't know what game this is, but basically you should get some sort of DAG, right? Whatever the dig is. Monkey Island, I think. Oh no, Scab Island. How about Monkey Island? Let's see if there's anything like this. All right. I don't know. I've never played this game. I don't know if any of these are puzzles. I don't think there are any spoilers, and certainly I don't think you can read any of the text. But there will be some sort of like dependencies. Actually, maybe. Okay, so whatever envelope is. So envelopes, there's some things with bananas and organs, and if you have, I guess, a banana and a metronome, you can do more stuff. And so that's how I think that people who design adventure games often think about them. And this, I guess, doesn't seem to be represented in the code. I'll do a search for puzzle just to see if it is. But this might be something that you would want in your adventure game editor if you were really into making adventure games. But that being said, maybe it's sufficient to just do that in some like vector graphic charting tool. It doesn't necessarily have to be in the game engine. So let's look for puzzle. Literally matches. Okay. And then I'm just doing it a second time to make sure that I correctly told Emacs that I wanted. Yeah. Okay. All right. So so that's going to be it. That's Adventure Game Studio. I think it'd be fun for if you're interested in games. This should be a relatively constrained and straightforward way to to make a game. It might not be like the greatest game ever created, but I think if you can write a story and you can draw things or conjure up drawings and things using AI, this might be a fun way to spend a few hours making something that people can play. So that's all for me.